Hi there everyone. Welcome to the video lecture series on complex variable. I'm Mayur Gohil. In this video lecture, I shall be taking up this question which has a special kind of understanding required. Now, the question is divided into two parts. Find the analytic function whose real part is u x comma y with this function they have given to us, and they have also asked us the second part is also find its imaginary part. Now let us see how to do such kind of question. Such a question may arise in your examination for maybe for 7 marks or 8 marks, or generally for marks higher than 6. Okay, maybe 6 or 8 marks question it is possible to be asked. Now let us see how to go about this kind of question. The first thing is, as usual, the way we do the simplification we will do. The thing is, here we write let f of z equals to u plus iv be an analytic function. After that we write down u x comma y. Okay, the given function u x comma y. Now here the function is quite long function. Okay, it doesn't matter, but we just have to be very careful when we have many terms over there, so we do not miss out any term while taking the derivative or doing the integration as and when whatever is required. So we just be very careful with the terms and the signs that are associated over there, the signature, the minus, plus, and all. Now we first find the partial derivative. So let us find the partial derivative over here. So u suffix x, that is dabba u by dabba x. While calculating the derivative, for the first term it is 2x, for the second one it is 0. Okay, the third one it is going to be 5. For the next one, the fourth term y is going to be 0. Now comes the thing, we have to do the partial derivative over here. We may do a u by v rule, or even you can do the product rule over here. It is okay. I'm going to do u by v rule. So it is here, it is minus, okay, denominator square x square plus y square the whole square is there. The first term, when I do here, if I do x square plus y square into the derivative of y with respect to x, it's going to be 0. So here it is 0 minus y times the derivative of the denominator with respect to x, it is going to be 2x. Okay, so that's the whole thing. So I'll just would like to write the answer here in a simplified form. That would give me 2x plus 5, and then there is this minus minus makes it plus, so 2yx divided by x square plus y square the whole square. That's the answer. This is ux, that is dabba u by dabba x. That is what I have got. Okay, so this is the thing, and this is what is going to be labeled as phi 1 x comma y. Okay, now let us find uy. Okay, so uy is dabba u by dabba y, and let's do the derivative over here. That's minus 2y. X square is 0 minus y square is minus 2y. 5x is going to be 0, and then the derivative with respect to y for y is 1. Here again u by v rule when we apply, so we get x square plus y square the whole square, and then the derivative of x square plus y square, no, derivative x square plus y square is going to be, as it is derivative of the numerator, that is y, it's 1, minus y times the derivative of the denominator with respect to y. Now x square is 0 and y square derivative is going to be 2y. Okay, that's the thing, and put a bracket because there is a minus sign ahead. So let's simplify here. So it is minus of 2y, okay, and plus 1 minus y, it would be minus of x square, and then there is minus 2y square, so it would be here it is plus y square and minus 2y square, it will be minus of y square over x square plus y square the whole square. Okay, that is the answer. And so this is going to be phi 2 x comma y. Now let's write down the generic steps that are always involved. Okay, so the generic steps are, I'll just put a separator. So they are here it is um, f dash of z is equals to ux plus I vx. Okay, and so by the Cauchy-Riemann equation we have this new formula for the derivative, that is ux minus I u y. Okay, f dash of z is this over here, and then uh, we have given them the name, so you relabel them as p1 x comma y minus I times p2 x comma y. You put them here by Milne Thompson method. Okay, you can write that. Sometimes it is so natural that you can even skip those lines by writing, but we'll just have here by Milne Thompson method, put x equal to z and y equal to 0. What do we get here is f dash of z is p1 z comma 0 minus I times p2 z comma 0. Now let us do that simplification. So with the moment we do that simplification, what do we see is here is in the first term over here it is going to be 2z plus 5. Okay, no change there. But the moment I put y equals to 0, numerator becomes 0, numerator upon denominator 0 upon denominator is going to become 0, so not a issue. So we have got our first term minus I times, what about here, the first term minus 2y collapses and we get 0, and then there is plus 1, so we write that 1, then minus, okay, inside the bracket there is z square minus 0 square, so that's gone, over z square the whole square, right, because there is plus 0 square, so that's going to be here. Now we simplify this, and what do we see here? Let us see how to handle it. So let's do the simplification. 2z plus 5, okay, minus I times 1 minus, it is z square over z raised to 4 basically, so it's going to be 1 upon z square. We do perform now the integration. So integral f dash of z dz will give me the integration of RHS. What we get is integration of 2z plus 5 minus I times 1 minus 1 over z square dz. Okay, now let us integrate this. What do we get? The first term is z square. Okay, uh, 2z integration is z square upon 2, 2 and 2 gets cancelled, so and then phi is going to be phi z. Okay, and then minus times I, and on simplification we will get here 1 like 1 integration is z, and 1 upon 1 upon z square, so that is basically z to the power minus 2. So the integration is z to the power minus 1 over minus 1 plus the constant of integration. Okay, so we can, for time being, we can avoid constant of integration, but it is okay if you keep it there. And then on further simplification we can see it becomes z square plus phi z minus I times z plus 1 upon z. This is the answer, plus c. This is what you are going to get f of z. Okay, this is what is there. Now let us go further, and now the thing is going to be important. So the same question that we were doing here, I have written down it again so that we don't lose the sight of it. So the whole thing is f of z, what we obtained was z square plus phi z. Okay, we obtained here is that minus I times z plus 1 upon z plus c. Now this c can be avoided for some time and it is okay. Now how do we get the imaginary part from this? So what we do right over here, we can write down to find the imaginary part. What we need to do, we do here the following. We put f of z equals to u plus iv, and z is equals to x plus iy. Okay, so that is what we do, and we will get our answer. So let us do that. So let's do that substitution. U plus iv is equals to x plus iy square plus 5 times x plus iy minus I times x plus iy plus 1 upon x plus iy plus c. Okay, let's see for some time. If we keep it aside, it is okay. It won't be of great difficulty. Okay, now let us see. Yeah, let us do the simplification. So this is x square plus 2xyi minus y square. Okay, because I square y square, it will give you I square is minus 1, so that's going to be minus y square. And then there is phi x plus I times phi y. Alright, now then there is minus of I x, then there is I square is minus 1, and that is minus sign is already there, so it's going to be plus of y. And then here we have a little bit coming into picture, it is minus of I over x plus iy. What we can do here is we multiply and divide the numerator and denominator by the conjugate of the denominator. So what we get is x minus iy times x minus iy is multiplied. Okay, so let's do the further simplifications here. So x square, okay, minus y square, then there is phi x. We are just collecting the real part and the imaginary part. So let us see what all terms can be collected. X square, phi, y square, phi x, then there is plus y, that is here. Now when we do the further calculations in the last portion, or let's see, we can do it in the next step also. So plus 2xyi, okay, plus 5yi minus ix. And here when we do the calculation, what do we get? Let us see. We here when we do is ix, or we can just keep it here ix like that. And then okay, we have this minus sign, we can keep it outside. We just multiply it here like this bracket we can put. So ix, and then there is I square is going to be plus, okay, so plus y, and divided by, then it is x square minus, basically it's going to be minus of I square y square. And so in the next step we get here x square minus y square plus 5x plus y. And then a bit of simplification here will help you out. 2xyi plus 5yi minus ix, and this carry out a bit of simplification here, so it is minus of, you can write it here ix. Now denominator can be separated, but then I'll separate it as x square plus y square, okay, and then separate this with the minus y over x square plus y square. That's how it can be. So these are the two terms here, okay? So that's what you have here. Okay, so now let us write the term that we have. I'll put a separator here. So the term on the LHS we have is u plus iv. What do we get here? On just collect the real part and the imaginary part. So we get is x square minus y square plus 5x plus y, okay. And then there is this term also is there, minus y over x square plus y square. This is the term that we obtain, plus now we take all the terms which are remaining, and I is common in each of the term. The imaginary number iota I is already there, so I times 2xy plus 5y, okay, this here, and then this, and then there is this x over here, minus of x, okay, and then there is minus x over x square plus y square. That is the answer. So therefore the imaginary part we just write down, therefore the imaginary part vx comma y is equals to 2xy plus 5y minus x over x square plus y square, okay. This is how we get the imaginary part when the real part is given to us. So first thing is, what you do here is this. So you have been given u x comma y, you calculate the function f of z, okay. F of z function is to be calculated, so we calculate that function f of z, and from f of z we calculate the imaginary part x comma y. So this is how the procedure is there. So from you use the Milne Thompson method, okay, and then you do the substitution of uh, z equals to x plus iy and f of z equals to u plus iv, you will get your answer. Okay. Now, one very important thing over here is that when we got the real part and the imaginary part, the real part in the question matches with the real part that we have found. Just see, this is the real part, and this is the same real part that has been given in the question. It must match. That assures that whatever we have done is correct. Okay, so this is the way most of the teachers also verify their answers, how they got whatever is there. Okay, this is mathematically how it is done. So I hope you have understood this following example, and you have it was a lengthy problem compared to all others that you have seen previously. Please go through the entire procedure once again, how to find out the imaginary part when the real part is given. If you have any queries, please feel free to write down in the comment section below. I would be happy to guide you wherever you have been stuck up. I hope you like the content. Please hit like button, share it with your friends, those who find this video useful. Subscribe to my channel, hit the bell icon. I'll soon see you with the next video lecture with a new kind of a question. Till then, keep solving good amount of mathematics. Thank you.